to learn to solve systems of equations, just like we talked about yesterday, 2 by 2 systems, with a method that's called substitution. And I wanted to start off with this is really an example of like a word problem about systems of equations, but I think it's kind of interesting. So right here in my hand, I have a whole bunch of money. And I dropped some of it. Right? And I actually happen to know that I have $5 here. I have exactly $5. A lot of money. I'm pretty rich.
Yeah.
Right? So, I also happen to know that I have quarters and nickels. Right? Quarters and nickels combined. And I also happen to know that I have 2 more quarters than nickels. Based on that information, once you understand systems of equations and substitution, you could tell me exactly how many quarters and exactly how many nickels I have. Which seems like kind of a silly problem, right? Like, why don't we just count them? Why don't I just count them? But when you know this method, you can solve any problem like this, no matter what. Yeah. It is similar to age word problems, and you could solve age word problems using systems of equations. I think systems of equations is the most useful topic in Algebra 1, because you can turn so many things into an equation, and then turn something into another equation, and then solve it as a system. Right? And the methods that we use to solve 2 by 2 systems are very similar to the methods that eventually you'll learn in Algebra 2 to solve 3 by 3 systems. And then you could even solve 4 by 4 and 5 by 5. You can solve all sorts of systems of equations using the same method. The trick is you have to have the same number of variables as equations in most cases. So if I have 5 variables, I need 5 equations to be able to solve. So when you looked at like those age word problems that had 5 different people, to solve those you would really need to write 5 different equations. But some of the equations would be very simple. Like, John's age is Adam's age minus 2. So it would be like J equals A minus 2. And some of them might even be like Fred's age equals 10. F equals 10. In Algebra 2, you'll see even more complex types of word problems. All right, so let's look at this actual problem. So what I just told you was, the number of quarters is equal to the number of nickels plus 5. Make sure I did that. No, I didn't. I said plus 2. Good thing I checked, because then it wouldn't have worked. Okay, and then I also told you that I have a total of $5. And I'm just going to give you the equation for that right now, which is if I took the number of quarters times 25 and 5 times the number of nickels, that would equal 500. Okay, who wants to graph this? Does anyone here want to graph this? No. No. That would be a huge graph. I mean, we could do it, but there's an easier way. There's an easier way to solve this. And it's called the substitution method. What we do, we look at the equation that has a variable isolated. And in this case, we already have our variable alone on one side. We already have it isolated. So in this first equation, I have something that says Q equals. To use the substitution method, you have to have a variable isolated in one of your equations. Okay? I could do that, though, if I didn't. Like, if it said Q plus N equals something, I could subtract N from both sides to isolate Q if I wanted to. So I can manipulate the equations if I need to. You're not going to have to do that yet. Okay? So for now, all we're doing is finding the equation where the variable is alone on one side. I like to use kind of what I call Gary's circle method to do the next step. So I say, here's Q. Q equals n plus 2. Here's Q. Q equals n plus 2. And then I rewrite this equation, except instead of Q, I'm going to write n plus 2. So that looks like this. 25, really important thing to do. I'm substituting something else for Q. So I put parentheses around it. Now sometimes the parentheses won't do anything, but sometimes the parentheses will remind you, I need to do the distributive property. And in this case, we do need the distributive property because Q is n plus 2. So I'm going to have to do 25 times n and 25 times 2. And then I have 5n equals 500. All I did was rewrite this equation here, except instead of Q, I wrote n plus 2.
I don't really get how you got the 25 and
25 is right here.
5. Yeah, but how did you get those?
Well, we're not going to talk about that today.
Oh.
We're just going to talk about solving the problem. Just looking at what is our actual solution. Okay. What is this?
45n.
But I mean, what is this equation? How many variables does it have?
One.
One. If we have one variable, we can solve it. So now, this is just a multi-step equation, right? Just a multi-step equation that we can solve for n. So I would use the distributive property. I'd have 25n plus 50 plus 5n equals 500. 25 plus 5 means that I have 30n plus 50 equals 500. Next step would be to subtract 50. So 30n equals 450. Divide both sides by 30. N equals 15. So this is stuff you've done before. You've solved one variable equation. You've used the distributive property, combined like terms. That's all review. The key is really this first step. Substituting in for one of the variables. And that's going to allow us to solve any system of equations. We could always use this method, but it's easiest when we already have a variable isolated. Yeah?
Wait, on a homework, will it be like that? Will you give us like the Q equals n plus 2 as an equation? All we need to do is substitute it?
Yep. So is this the answer? N equals 15?
No, because you have to
No, that's
find out how many
nickels plus 2 there are, so there'd be 17 nickels.
So there'd be 15 nickels and 17 quarters, right?
Yeah.
15 plus 2 is 17. So all I'm doing to find Q is I'm taking this and plugging it back in here. So I'm kind of using substitution again. I'm saying Q equals 15 plus 2. Because I found N. So then Q is 17. And that is my answer.
Wait, is that how many quarters and nickels you actually have?
Does anyone want to count them?
You have to all keep them.
You can't keep them. But you can count them if you want to. Alright, you count. We're going to do another problem. We're going to do another problem. Alright. Let's look at this one. This one's actually going to be simpler. So let's say I have this. Y equals 5.
I got 17 quarters.
3x plus 2y equals
Yep, it's correct.
13. That's correct?
Yep.
Okay. Here are my two equations. So write those down. Show me what you think the first step is in your notes.
Find all the right here.
What's our first step?
To switch y for 5.
Yeah, I'm going to find y equals 5. So I'm going to switch y for 5. So then I have, let's see, 3x plus 25 equals 13.
New? It's
No?
times 5. So it'd be parentheses
Oh.
or 10.
Parentheses.
Which would turn into 10.
And this turns into 10. Okay. So I've got 3x plus 10 equals 13. Oh. What is my first step then
Let's subtract
to solve this? Subtract the 10.
x equals 1. X equals 1.
3x equals 1. And we're done, right?
No,
No.
we have to find out what y equals.
Oh.
Y equals 5. Yeah, y. Oh,
Y
yeah,
is 5.
Five.
Yeah. And when we have problems with like x's and y's, I prefer that you write your answers like this. 1, 5. Why do I prefer that, you think?
Because x and y coordinates.
Because it's x and y coordinates. This reminds us of what?
Which one is which?
Okay. It also reminds us of graphing. Because even though we're not solving these by graphing, we could. The quarters and nickels problem, we could have made a quarters axis and a nickels axis and graphed. X and y, we could make two different equations, and I mean, we could make two different lines and see where they intersect. And it would be at the point 1, 5. That's where these two lines would cross.
Would that be the answer for the standard form thing?
Uh-huh. What do you mean?
Couldn't you change that to standard? Couldn't you, like 3x plus 2, couldn't you use standard form for that?
We could use standard form to graph this. Now, is it going to be a simple one to graph? Not really. I mean, because we're going to end up with like 13 over 3 and 13 over 2. Those aren't the best, those aren't the easiest intercepts to graph, right? So it's going to be one of those ones where we'd have to make a really precise graph, right? It might not work with our usual methods of graphing. And so that's why substitution is easier to solve something. Let's just graph it though, just so you can see that it really is true. Y equals 5 is a line like this. Let me use color. So y equals 5 is a line like this. One, 2, 3, 4, 5. 3x plus 2y, let's use red. We could make a t-chart. If x is 0, y is 13 halves, which is 7.5. Right? So my intercept is, if that's 5, 6, 7, 8. My intercept is right here. And then if y is 0, x is 13 over 3, which is 4.335. So 1, 2, 3, 4, 5. So here's my line. And we can see that that crosses right around this point. But again, I didn't draw it perfectly, so it looks kind of off,
Yeah.
right?
You can't draw the decimal.
And I can't, yeah, it's hard to draw these decimals perfectly. But I think it's close enough for you to believe that that's really where they cross. 1, 5. So we're doing the same thing. This is just, I think, a better method. Right? It's more accurate. It's more useful. It doesn't depend on our graphing skills as much. All right. I'm going to put up a problem from your homework, and you're going to solve it in your notes. This is problem number 7. Y equals negative 8x. Y equals 6x. So let's talk this through. And on your homework, once we get the answer, you can just write in the answer. So this is problem number 7. You might want to make a note in your notes. What would be your first step?
You would substitute negative 8x. No, wait, you have to make that. Or no, well, you just do that.
So substitute negative 8x for y.
For y.
Now this is kind of interesting because technically I could substitute 6x minus 14 for y too.
But you have to pick one, I guess?
We have to pick one. Also, it would be the same equation, right? If we think about it. Either way, it's going to be negative 8x equals 6x minus 14. Either way, we end up with the same equation. So y equals negative 8x. So I circle the negative 8x. I plug that in for y down here. So I have what? What do I have? Negative 8x equals 6x minus 14. All right? What might you do to solve this? What would be your next step? Add the 8x to both sides. And what do we get when we add 8x here? Here. Right here we get 0, right? What's 6x plus 8x? 14x. Minus 14. Okay, so now we add 14 to both sides. Yeah, there's more than one way of solving this, right? You should get the same answer, though. What do I have now? Okay, that's what I'm going to get in a second. What do I have first?
14 equals 14x.
You guys are like too fast for your own good sometimes. All right, and as you guys all saw, divide both sides by 14, so 1 equals x. Perfect. Are we done? No! We're so used to being like x equals this and being done. But we're not done. Why are we not done?
We need to plug it in.
We need to plug it in. So if x is 1, what is y?
Negative 8x.
Y equals negative 8 times 1. So y is
1 negative 8.
negative 8. So our point is 1 comma negative 8. And that's the thing you're going to put a big old box around on your homework. All right, questions? Pretty straightforward? Substitution method? Good.